NWU FETE 121 Electrical Technology for Teachers, Faculty of Education at the Vaaltriangle campus. My name is Mr. FETE and I am your lecturer in this subject. Hope you will have an enjoyable and successful semester. Study Unit 1, Basic Concept and Sources of Electricity. The generation and fundamentals of electricity. Just what is the importance of electricity? Development and generation of electricity changed the lives of ordinary people drastically, starting from domestic use to industrial activities. Like air and water, people in this day and age is very dependent on electricity. A lot of very important outcomes makes exclusively use of electricity. That includes lighting, cooking, heating and cooling homes to powering televisions and computers. Basic principles of electricity. First of all, we need an energy force to produce a voltage, which is measured in V, volts. And when there is a closed circuit, current can flow. That is, electrons moving in one direction through a conductor, and it is measured in amps, indicated by I. Any circuit also displays some sort of resistance. Resistance limits the flow of current, and it is measured in ohms, indicated by the ohm symbol. There is a strong relationship between V, I and R. If we have a look at the diagram below, we see that I equals E or V over R. Likewise, E equals I times R and R equals E or V over I. Electricity, of course, does some work for us and is indicated by the letter P, which stands for power. Therefore, power equals I times E and I equals P over E and E equals P over I. We will do a few calculations later on with regards to these relationships. Different sources of electricity. Chemically generated, like batteries. Mechanically generated, like generators. Optically generated, like solar panels. Statically generated, like two materials at different potentials. Static electricity. Static electricity is the build-up of positive or negative charges on the surface of an object. These charges build up when two objects rub against each other and electrons pass from one object to the other. An example of this would be the shock you get from touching a metal doorknob after walking across a carpet floor. Chemical electricity. Batteries transform chemical energy into electrical energy. When the positive and negative terminals are connected so that electrons, in other words electricity, can flow between them, usually through a wire, conductor and copper mostly, chemical reaction occur at the electrodes. These reactions release excess electrons at the cathode, which flow to the anode. Mechanical electricity. The energy acquired by the objects upon which work is done is known as mechanical energy. Mechanical electricity is the energy that drives a rotating coil, that's the mechanical action, of conductors through a permanent magnetic field. Let's have a further look at the different types of cells. First of all, the primary cell. That is a cell that cannot be recharged. A secondary cell can be recharged by applying a current in the opposite direction to the discharge current at a voltage slightly more than the EMF of the cell. The single cell. A cell is a single unit but can be connected in parallel or series, called a battery, to get the desired effect. The total voltage of this setup equals 1,5 volt because it is connected in parallel, but it has a much larger capacity. The total voltage in this configuration equals, of course, V1 plus 2 plus 3 plus 4, which gives you 6 volts, and that is, of course, a larger voltage than one battery alone. The Leclanché dry cell. The electrolyte is a paste. The EMF, or electromotive force, of this open cell is about 1,5 volt. It is made up of a metal jacket, which also serves as the negative terminal. Then we have the positive terminal, as indicated at the top, connected to a graphite rod. Then we get the paste, which is made up of the different chemicals and insulated by an asphalt seal. Button type silver oxide cell. This is a very small type primary cell. The anode is at the top as indicated. The containment can, which also serves as the cathode or negative, and then of course the electrolyte within. Rechargeable nickel-cadmium cell has an alkaline electrolyte and is fully rechargeable. It has more or less the same construction as the Leclanché dry cell, but is made up of different layers of the different chemicals, which serves as either positive or anode and negative or cathode material. Lead acid battery, consisting of pasted plates called Forer plates. One plate is made up of a grid of lead and antimony, which contains the active material lead oxide and sulfuric acid. This negative plate, called the cathode, and is placed together with the anode or the positive in a solution of sulfuric acid as the electrolyte. The positive plate of this battery is identical to the negative plate, except that the material changes to lead dioxide when charged. It becomes dark and is called red lead. The plates have also got separators to guard against physical contact. Charging the lead acid battery. DC, or direct current of a higher voltage, must be connected to the positive and negative terminal of the battery. The positive side slowly becomes lead dioxide as the charge progresses. The negative side then becomes a spongy lead. The electrolyte is a mixture of sulfuric acid and distilled water. EMF, or electromotive force, relative to the density of the electrolyte. The EMF of one of the cells is normally approximately 1,2 volts. The relative density shows the ratio between electrolyte and distilled water. This should usually be 1,23 and 1,28 on the scale of the hydrometer. Seeing that this is a ratio, it has no unit. The hydrometer on the right hand side of this diagram indicates fully charged state. What is meant by the capacity of a lead acid battery? The capacity is measured at a rate of how many amps it can deliver per 20 hours. Therefore, an 80 amp hour battery can deliver 4 amps for 20 hours, seeing that 20 goes into 80 4 times. The capacity depends on the number of amp hours and the size of the battery, the rate at which it can charge, the ambient temperature, and also the age and condition of the battery. When is a battery fully discharged? The cell potential must be 1,85 volts or lower. The specific gravity drops to below between 1.72 and 1.200 as measured on the hydrometer.